Hi, good evening everybody. This is Sandeep Giri here. The session has been started. The session has been started. So now you guys should be able to hear me. If you are not able to hear me, let me know quickly. Or at least if you are able to hear me, just respond quickly. Hi everybody. I am Sandeep Giri. Hi Gaurav. Hi Shashank. Hi Kritika. Hello Ashan. And hello Sumant. Please, everyone, please introduce yourself before we start. I'm so sorry. I think one of the audience is calling me. Hello. Yes. Yes, Sandeep here. Um, you should try to disconnect and reconnect, and do not. Use Google Chrome. Okay, madam. Use Google Chrome, and you must have got a Hangout URL. Try again in different browser. Okay. I'm this last one. The last one I have sent in the SMS. That is the correct one. Please use that one. Okay. Thank you. The session has already been started. So guys, please introduce yourself. It will be great if we know each other before I start the session. And please start introducing yourself. Those in form of Q&A app. Since Google Hangout do not allow more than 10 viewers at a time, and other solutions we do not have great reliability. I have tried WebEx and GoToMeeting and others. There is always a fallout rate. That is why I'm using Google Hangout. So in the Google Hangout on air, you cannot have more than 10 participants. That is why I have chosen completely that all the people will be viewers and they will communicate using Q&A app with the instructor. Okay, so please introduce yourself using Q&A app. Are you able to see the Q&A app? In case you are lagging in the history, click on the live button so that you come to the live session. So the session in terms of it has sort of started. We want everybody to introduce themselves and using the way of Q&A app. So please feel free to introduce yourself. So I think all the people can see the questions of other people, right? So Bhagwat has introduced himself. He's joining from Atlanta, USA, and he worked there in the satellite image processing. And he's from IIT Roorkee 2003 civil engineering batch. And he's actually one of my college junior. And he's also has attended our MongoDB sessions in past. And so Bhagwat, are you able to hear me clearly? Amandeep, try reconnecting to the Hangout. Try opening the Hangout URL again and see if your audio is fine. See which default device is connected. Hello, Ankit. So we have got a great set of audience. We have got 15 audience right now, and more will be joining. Now 16. And I would love to hear from all the people. I would love to understand. Okay. So I would love to understand from you guys about yourselves. Great. So it's 8:30 now. Amandeep is not able to hear. So we have Anto Alex from Uruguay. He is working as automation engineer. Awesome. And Shashank, actually, there is no way to connect back. Hello? Hello? Let me ask some more people. Uh, whosoever is able to hear me, please respond. So Amandeep is not able to hear, and now Anto Alex is also not able to hear. Sashank is not able to hear me. Okay, okay. So, but Bhagwat is able to hear me. Ashan, please check your audio settings. It seems that the audio is going fine. So kindly says some of us are not able to hear. Arvind is able to hear. Clareson is able to hear. And Gaurav is able to hear. So let me type it for the people. In case you are not able to hear, please close and join back. Okay. Okay. Now let me just please introduce yourself. Okay, great, great. So I think at least some people are able to hear. So probably the problem is not on my end. And those who are not able to hear, please close and join back. Okay, so Great, great. Let's start the session. Awesome. Let's start the session. So I would like to start with getting the introduction from everybody. Some people have already started. Some people have already introduced themselves. So, hello Ishan, welcome to the session. Ishan works at Dell India at R&D Center. Great to have you here, Ishan. And I would like to have an introduction from other people as well. Hi Gaurav. Gaurav works at Pitney Bowes Software. Welcome Gaurav for the Hadoop class. Sukhsawat is a master's in data mining specialization, and he works in the data mining as well. Himanshu is not able to hear. Okay, if you are not able to hear, then how will I communicate? Okay, so if you are not able to hear, please close and join back. That's the all I can do. Okay. Everybody else is able to hear. Hi Arvind. Arvind is currently working on Java J2E platform in Noida in Aristocrat online gaming platform. Great. Great to know you, Arvind. Great. So I think now I shall move on. So welcome to the Big Data and Hadoop session by knowbigdata.com, and these are the common features of our classes. We focus a lot on asking questions. So no matter what kind of question it is, feel free to ask us. Okay. And once the class is over, all the audio as well as presentation, quizzes, everything will be available online in a learning management system, also called as LMS. And the access to that system will be lifelong if you are our student. And all of the classes are recorded, all the conversations are recorded to ensure that you can revise in future. I'm so sorry, I'm getting another call. Hello? Yes? Yeah? Yes? So please try using Chrome or some other browser, because all other candidates are able to see that. Okay. Okay, thank you. Actually, I'm in middle of class, so yeah. So everybody is able to hear. There are already 14 candidates. They are actually able to hear. Okay. So please check your audio settings. Okay. Okay. So maybe they are using some old link. That is why they are not able to hear. Probably this is the last time I am going to just send them a quick message telling that the URL again. And yeah, so I'll just send some of the people messages. Just excuse me for a second. And this is a little bit common in first class when people have not prepared the hardware. Okay, okay, okay. Himanshu is running his own startup. He's from Soap Poke, and he was working with Google. Welcome, Himanshu. Nice to see you. And as we spoke on the phone, let's have the discussion carry on. And we have got a great 18 viewers today, which is a great numbers to have. And welcome, Amandeep. Amandeep is also from Pitney Bowes with Gaurav. Okay, okay. So Rohan is able to hear after you opened in a separate window. I'm extremely sorry. There's somebody else. Hello. Yes, Sandeep here. Oh, I've just sent you another. Should I send you another URL? You try with that? Oh, oh. Uh, please check the settings. Right, right. Oh, okay, okay. So try to open it in Firefox or Google Chrome and try to check the audio video settings and try it. Oh, okay, so please check something else because I'm in middle of class and yeah. So okay, 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 great. Hi Rohan, welcome to the class. Rohan is a DBA from Bangalore, and then we have Vijay Rathi, who is also Pitney Bowes, and great, great. So there'll be a little bit of problems with respect to the hardware's bit. Okay, and it is quite common because we have more problems when we use WebEx and other platforms. This will just die down now. Great, great. So then I was talking about what kind of learning we provide. We provide the lifetime access to the whole content so that you can revise it at any point of time, as well as we provide a cluster access to you. Okay, what does it mean by cluster access? Instead of because all of the big data technologies require a lot of computers to use, which of course you cannot have it at your end. So we generally buy a temporary cloud for a class so that all of the class can experiment on uh, those servers. Okay, based on the requirement, we purchase these servers and then dispose of at the end of session. Basically, not at the end of session, after the project of the people finish. So at the end of class, we give a project which is generally from a real life experience of the instructor, and a real life data is given, a public data is given to the people so that they can experiment on it, and all of this project is to be done on our servers. Okay, also you are free to install on your machine, install all of the tools, we encourage that, but we also provide you a cluster of our own so that you don't have to worry about setting up things. Okay, you can experiment, you can learn how to set up and everything on our servers. Because in an organization, the way it happens is that you generally have to set up all of these technologies tools on a cluster instead of your desktop. Okay, so we try to provide you the real life experience of the actual work in the big data technologies. We provide you a certification as well as we give you a lot of quizzes and assignments so that you learn at the right pace in a proper manner. In case of Hadoop, there will be 10 classes, each of 3 hours, and we provide a socio-pro visibility in the sense that we provide the recommendation and endorsements on LinkedIn, on various technology, on the technology which you have studied. Okay, as well as we provide a lifetime link to your certificate. The certificate is in the form of HTML page as well as image, encrypted image, and it's digitally signed, so that your certificate is searchable from the Google itself, as well as your there is a digital certificate also which is signed by our private key and can be viewed in any PDF viewer. So those are the kind of things we try to provide you in the socio and professional visibility section. Okay. Then we also help people in their mock interviews. Lots of people are generally looking for a career upgrade or knowledge upgrade. A mock interview actually help people to understand and measure how well they weigh against the industry. Okay, so these are the mock interviews are separate from the main classes. These are demand based. If you want, we can have mock interviews to be placed. Okay, great. So Amandeep is able to hear, Neeraj is able to hear, and great, great, great Amandeep. And Omkar is able to clearly hear. Amandeep is also from Pitney Bowes. Shashank is an Oracle DBA, and great to have you, Shashank, here. Great. We have got 21 viewers as of now. I'm very happy because none of the other software weigh well for 21 users. Now, now about me, I'm a graduate from IIT Roorkee. Then I worked in the big data domain in DSHA. We were doing a fraud detection, and DSHA is well known for having 10,000s of computer grade in 2000. When I joined, I was working on the grid that time itself. And then I started a company called Tbits Global, where I was doing a document management system for ERPs. This was not a very, very big data game, but it required a lot of architecture and B2B knowledge. Then I joined InMobi. That's where I enjoyed again my big data knowledge. I churned around 200 terabyte of data to build a recommender system. And then at Amazon, I had been working on high throughput system because our team was handling the detail page. Okay, so this is the kind of background I come from. Okay, so and I have realized that I enjoy delivering lectures. I enjoyed explaining very difficult concepts to all my friends all the time, and I try to explain the toughest thing in the simplest manner, and that is why I have started to deliver the content, deliver the instructions and the lectures. Okay, so feel free to ask me any questions at any moment of time. At the end of every slide, I will answer your questions. So, hi Lakshmi Vera. Lakshmi Vera is from, Prasad is from Dell. Shashank, great. Shashank is able to now hear it clearly, and Alex as well. Great, great. And welcome Omkar. Omkar is working as software developer in ACI Worldwide Pune in a corporate banking product. Great to know you, Omkar. Hi Anil. Anil is from Dell. Great, great. Shashank is able to clearly hear. Pretty good. Great, great, great. We have got a great class today. And so these are the topics. These are the 10 classes which we are going to deliver. And today we are going to talk about big data and Hadoop architecture. In today's class, these are the things which we are going to talk. It would not make much sense right now, but it would make sense to revisit this slide at the end of the class again. So now let's jump in. Let's jump in. So what exactly is big data? What do we know about big data? Let me see your feedback. So what exactly do you know about big data? Hi Nurit Mir, he works as UCLA as a developer. UCLA is University of California, probably. Hi Nurit, and welcome to the class. Great to have you here. So what exactly do we know about big data? We hear this term a lot in these days. I'm waiting for your answers. Okay, I think it is taking some time. Okay, Sukhsavat says a lot of data need to analyze. Okay, okay. Hi Prasad, Prasad is with Dell. He's from California and he's working on J2E and Java technology. Welcome Prasad to the class. Huge and frequently occurring data. Nice. Okay. Great. Nurit says a lot of data from different sources. Nice. Arvind says that a data available in huge quantities. Gaurav says big volume of data with variety, different schemas, and which is growing with time. Interesting. That's what actually it is. Different formats. Yes. Rohan says data in unstructured format. Okay, okay. Interesting, interesting. Okay, okay. So in my opinion, none of the answers were wrong. Okay. It just big data means it's a terabytes or petabytes of data. Okay. And the definition of big data is like definition of rich. Okay. There is no clear definition. It's just an adjective. Okay. It's a huge data in terabytes or petabytes or exabytes, which you cannot process using your usual tools. What does that mean? So for that you try using your MySQL database for 2 terabyte of data and try searching for something. That time you will realize that 2 terabyte of data is too much for a MySQL. Okay. Or try storing 200 terabytes of data. Then you will realize that your existing systems are not good enough to handle 200 terabyte data. And that's when you say, so this data is big for me, or this data is big for my kind of needs. And this data could be structured, unstructured, whatever format, but it is data. So in very simple words, a big data is data of huge size which you can't process with your usual lines of tools, which means that a million records is a big data for an Excel sheet. Okay, so it is that way. So big data is always defined in terms of the way you look at it, and people have tried to define it, but my thought process is that big data is just a term, like rich. Rich is just a term. It's an adjective. It shows that people are rich, but there is no clear-cut definition. Okay, and big data problem and big data are two separate things. Okay. There are multitude of problems which we characterize as big data. When we are not able to solve it with the existing infrastructure, we start telling that it is our big data problem. It could be anything. It could be anything. But in simple words, big data is something, a huge amount of data, and which you can't process using your existing tool just because it's huge. If the same data is smaller in size, your existing tool are able to solve it. Okay. So that is what is a big data. Now, IBM came up with the funky answers, funky definitions. So first they said there are 3 V's that define big data, and then there are 4 V's that define a big data. So this slide is specifically for those who are looking for definitions. Okay. And people ask you when you are discussing with them, what are the 4 V's or 3 V's of data? So first 3 V's are volume, velocity, and variety, and fourth V is veracity, which was recently added. Volume, everybody knows, a huge volume of data which you already have in your organization. And then velocity, the rate at which the data is being added. And then variety. So variety of data is, earlier we used to think of data only in terms of relational database terms, and having a binary file being stored in the database was an awful exception. So data was only the database was only meant to handle the structured data in tabular format. But nowadays, unstructured data means the data which is not ready to be consumed by the program. You need to convert it into a understandable format. You need to parse it to convert it into a reasonable format. And that's when the structured unstructured definition come into play. Okay. So variety of data. Earlier, we just had those tabular format data, but nowadays, think about Facebooks, think about Googles of the world, think about Amazons. They have data in all format, and that too huge. It would be audio, video. As we are speaking, an audio is getting recorded and being uploaded onto YouTube. Okay, so that's a data. I mean, that's a data in motion and in variety. You have videos, photos, audios, music, and you have maps, geospatial data, and all sorts of data. That's a variety of data. And then the fourth word comes up from IBM called veracity. Okay, veracity is something like data in doubt. Data in doubt as in the data which might be a derivative data of the other section, or it might be a data which is inconsistent, or which you might have to delete at later point of time, but it is still a data. Okay, so these are the 4 V's from IBM defining all sorts of data. So a quick question. Gaurav is saying that he is not able to hear. Guys, okay. Okay, maybe you close it and then open, then it will work. Great. So how many bytes are there in petabytes? Before I move on, just to just to check whether you are listening and you are able to see the screen and you're not sleeping. So how many bytes are there in petabytes? Guys, please answer me. So how many bytes are there in petabytes? Mhm. Probably it takes some time to reach me. 10 to the power 9. No, that Neeraj says that it is 10 to the power 9. No, that's a gigabyte. So Neeraj, that is gigabyte. Anybody else? 10 to the power 12. That is 10 to the power 12. Anybody else? Neeraj? That is terabytes. Gaurav says 2 to the power 15. No, it's actually Gaurav. Do you think it's 2 to the power 15? 2 to the power 15 is how much? It's very small number. 2 to the power 15 is 2 to the power 15 is very small. 1000 GB. No, that is terabyte, Bhagwat. Okay. So when we talk about data, so the term which you will hear very frequently is petabytes. And before we move on, let me just show you a chart. Okay. Onkar says 1.1259 e to the power 15. Definitely, Onkar, you have copied from Google. And yes, so Nurit is right. And so it's in order of 10 to the power 15 bytes. Bhagwat, yes. So Bhagwat says 10 to the power 16. Okay. Okay. So it's 10 to the power 15 order. And yes, and 2. So now everybody has got right. Now, an easier way to remember it is in terms of this. So there is a order of 10224, which is one close to 1000 that we talk about all the time. So kilo, mega, giga, tera, peta, exa, and then zeta and iota. So peta, exa, zeta, iota, these are the four things you might have to remember because everybody knows about tera. Okay. So after tera comes peta, which is 1024 terabytes, and terabytes is 1024 gigabytes, and gigabytes is 10 to the power 9. Okay, that means we have 10 to the power 15. Okay, so every time it increased by 10 to the power 3, which is okay. So 9, 10 to the power 9 plus 6, 9 to. Ishan Gupta says 2 to the power 160. Oh, that I need to check. Okay, okay. So 1025, yes, you're closer. But that will be, it will be 12, Gaurav. 1024 to the power 12. Great, 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 great. Thank you, Anto. And we have got all the answers. Let's move on. So this is the, and 1 byte is 8 bit. 8 bit can store 256 states, which means 256 characters a single byte can store. And now you can imagine that when we talk about a byte, we are already storing a 256 numbers in there, those. Okay. So a petabyte is too much of a data. Okay. And just to measure, I will throw a couple of more questions later on, which will, give a kick. How big a petabyte is, a terabyte is. Okay. Now let's have a look at the data. The way the data has been increasing is fast and extreme. And why we talk about big data suddenly? Why the world is talking about big data? It's not fashion. It started as a fashion. The term itself sounds fashion. But the truth is the data is increasing. Data is increasing at an extremely fast pace. You see, the non-green section, I don't know what color is that. This non-green section is digital storage, and the green section is the analog data. Now, in the beginning, we had most of the data in form of records, I mean magnetic tapes, and those kind of data. But later point of time, the moment the digital era started, when the internet started becoming public and people started having access to the internet, everything started moving to the internet. Now, as we speak, everybody is generating a lot of data, and people are storing that data. Okay, so the data has tremendously and exponentially grown. And in 2007, 280 exabytes of data. And exabyte, you know, how much is exabyte? Exabyte is 1024 petabytes. Okay, it has got 18 zeros. Okay, in it. 10 to the power 18 bytes is an exabyte. Now think of this. 2.8 into 10 to the power 20 bytes of data was there in 2007, and at the same pace, if you measure it, it will be tremendously high now. There are lots of services which we are using, and there are lots of data is being generated. So there is definitely a need of tools, technologies, and people who know tools and technologies to handle the big data. So this graph is a classic graph which is being used again and again. And when does the big data becomes a problem? These are the four basic resources when we talk about computing. First, starts with storage, RAM, CPU, network. But the order we are talking about is CPU, which means that for any computation or storage, the first thing you require is CPU. And then you require RAM, from which the CPU will read. And in RAM, we store the things which we want to process, which our code need to process right away. And then we have disk. And with respect to RAM as well as disk is a persistent storage where we store the data, but disk is very slow as compared to RAM. So the speed of RAM, size of the RAM, disk size, and the speed. SSD, for example, instead of your normal magnetic hard drive, if you use solid state hard drive, it is very fast in access. Okay, so all of these characteristics of the system govern how whether you can solve the big data problem or not. And these will state you when you are being forced to actually switch to multiple computers or your existing hardware becomes a bottleneck. Okay, and the fourth one is network. Say you are using your server, your machine to process some data. The data has to come from somewhere, or uh, you need to store the data back onto the network drive. You have enough of storage, you have enough of RAM, you have enough of CPU, but your storage is in the network. That time your network will become the bottleneck for you. Okay. And when we deal with big data, at least one of these four things become the bottleneck. And that's when you realize that you need to move on to a big data solution, or you need to devise your own solution in the form of a cluster. You have to use multiple computers. So do you guys have any questions right now? Hi Rakesh. Rakesh is from Mainframe IBM. Welcome to you. Now let's talk about this next problem. So do you have any questions till now? So let's take a simple case. You have got 100 terabyte of movies, okay, and you want to store it. These movies could be in various form. It could be your media campaigns, internal organization, or it could be, you have downloaded all these movies from internet, which is illegal. So, but nevertheless, you have 100 terabyte of data. How are you going to store it? And remember, you have to access this data. Using your existing tool, how do you how do you store 100 terabyte of data? This 100 terabyte is in the form of, say, files, small files, big files, and all sorts of files. And how do you give the access to these file systems to the people? I'm looking for your questions, answers in the form of Q&A app. So Bhagwat is saying, why would you store unstructured data all in one database? So, I mean, it's up to you. How do you want to store it? We have got 100 terabyte of data. Storage cluster. What form of storage cluster are we talking about, Ishan? So Ishan says that storage cluster. My question is that what kind of storage cluster are we talking about? And then how are we going to access it? Your answer is quite close. Right. So Gaurav says that we can store as cluster of nodes in grid storage. So you are actually one step ahead, and that's actually the sort of answer I will be giving. So let me save it for the end. Right, right. Great. So we unanimously agree that we need a distributed storage. So few years ago, what people used to do is have 100 terabyte of data and put it in the network and make 100 subfolders in your system and mount these at single place. Now, there used to be a lot of problems associated with it. This was fine as the first step, but hard disks fail all the time. Okay, hard disks fail all the time. And there has to be a backup as well as failover. There's a difference between failover and backup. Backup is you have a backup there, but it does not hot swap right away. Failover is you can immediately shut down a node and bring another computer in place. Okay, so since hard drives fail all the time, network fail all the time, data centers are damaged all the time. So we need to have a backup. We need to have the failover. This solution will be very, very inefficient. Then we said 100 subfolders we are going to create and mount these network there. Network drives onto those 100 subfolders. How are you going to divide the data? If you give a user some users access to one folder and another some other users to another folder, you will have to manually distribute these people, and you will always be in this juggling mode that move some users from first server to another server and then second people to the third one and add some more people on the fifth one, and that movement will consume a lot of energy. and it will consume a lot of time also for the user. Your turnaround time is going to be slow because every time the data is growing at one node, you are doing it manual shifting from one place to another. And third or fourth question is this the best value for money? Is 1 terabyte is the optimal cost as of today? Okay, as of today, I believe that 500 GB is the best value for money. Return, I mean, the ROI of 500 GB is the best. So why don't you use a smaller hard disk, whatever you have available in your on in your organization already? Why can't we use all of those together to form a distributed network? What about increase if we try to add those many hard drives using those so many folders, you will end up in a very huge management headache. And what about increasing availability? This is a very strong point. So let's imagine that there is a big file, say 80 GB Blu-ray file, which it is a newly released movie and all of the people want to watch it in this network what you have just created. Now, if it is stored on a single machine, or so what you will end up is that all of the people are hitting that single machine. Had you divided this file into 80 pieces and put it on 40 servers separately, your headache, your load will be distributed on all the servers, and your accessibility, your throughput would have been far better. So that is the challenge with respect to these kind of solutions. Now, if we now if you see, the solution actually is a distributed file system which does all of these problems, solves all of these problems for you. Does a failover, backup, distribute data uniformly, and helps you with the smaller hard disk, all the commodity hardware. You don't have to invest too much in hardware, new hardware. You can use your existing hardware. And increasing availability it gives you, and that's when a distributed file system comes into. These are the criterias for creating a distributed file system. And Hadoop distributed file system, also known as HDFS, does a very good job for this. There are multiple such systems which help you in solving these problems. Hadoop is one such thing. So Asan is saying a group of storage boxes attached to a server. So group of storage boxes again will have the same, these 4 or 5 problems which I just discussed. Okay. Now let me just challenge you. So we talked about a storage problem. There is always a storage problem. There's a first step. There's a first kind of problems, and you will notice this pattern when I discuss further. So there are generally two problems. One is storage problem and another is processing. So what exactly is processing problem? Let's say you have 10 million names of people. Just imagine 10 million names, meaning 10 to the power 7 names of the people. It's not a big thing. If you are in a government project where you are registering people all across the country, 10 to the power 7 is not a big number. Okay. So you are having 10 to the power 7 names of the people, and each name is 100 character long. Okay. Meaning 100 byte into 10 million bytes will make a 1 terabyte. Now you have to order these names in a in a ascending order. How much time do you think you are going to take on a computer which is 1 gigahertz processor and 2 GB of RAM? You have a computer, everybody's personal computer is probably gigahertz and 2 GB RAM. So how much time do you think it is going to take? Just give me a rough idea. Hours, days, months, minutes, seconds, milliseconds. You give me your answer. Give me a rough answer, whether it will take milliseconds, seconds, hours, days, months, weeks, years. How fast can you order 10 million names? 10 million names is 1 million has 6 zeros. So 10 million has 7 zeros. 10 million names having 100 characters in each. Okay, okay. So Gaurav Gupta says hours. Anybody? Hours means that it is something between 1 hour to 24 hours, right? Or 12 hours. So Prasad is probably not watching. Uh, Prasad, please click on the live button. Guys, click on the live button because you are probably lagging in this Google Hangout. Okay, so you're probably watching the preview. You are in the history. Okay, so Nurit says 1 minute. Interesting, interesting. Neeraj says minutes. Gaurav says hours. Anybody? Bhagwat says 5 hours. Anybody else has an answer? Bhagwat is right because he has already attended a class. Okay. So yes, it it took me with my best algorithm around 5 hours, and I tested with other people on internet. They could not get better than 4 to 5 hours on a sort of a 1 gigahertz processor. It's not dual core, it's a single core. Okay. So yeah. So Gaurav and Bhagwat were very close. And it will definitely, no matter what algorithm do you use, you will not be able to sort the names of people or strings, random strings below 5 hours on a 1 gigahertz processor on 2 GB, because the best algorithm is n log n. So Isan says that 50 minutes. How did you reach to that number? Okay, I have not seen a person able to um, sort it below 4 to 5 hours, not even with a solid state hard drive. I've tested it on my on a, I mean basically 1 TB definitely cannot be stored in a solid state hard drive. So in my scenario I was not able to bring it below 5 hours. Okay, so the question here is 5 hours good enough for you when you are sorting 1 terabyte of data? Okay, which is names of 10 million people. It's not a big deal. 10 billion people, not million people. I'm sorry. Okay, okay. So this is, we are talking about 10 billion people having 100 characters each is 1 TB. And we are talking about 2 GB RAM. It has taken me 5 hours. I could not bring it below that. So we always need a faster sort. Okay. And as the data grows big, the graph goes horrible. It's not linear. If you put 2 terabyte, it will not be 5 hours. It will be far more than that. Okay. And this 5 hours also include the read speed of your hard drive. It includes your network speed. It includes all the sort of things like CPU, RAM, the rate at which your RAM is spinning, and the rate at which you are able to read the data from the network, from the disk, and how much big RAM you have. If you have a bigger RAM, then you will be able to sort it better. And why am I asking a sorting problem? The reason is almost every problem related to data could be converted into a sorting problem, except for the graph algorithms. See, let's take a case of select statement, where there is a where clause in which we search for something. Now this searching is index based. Now indexing is internally a sorting problem. So every time you are inserting a record, it is actually updating sorted elements in the already created buckets. So select statement of SQL query is a sorting problem or searching problem, because for searching you need to have a data sorted already. Then other statement like select XYZ from a table, order by this, that is upfront an ordering problem where we are ordering the data. Then we have group by. Group by ID. When say group by under the hood is actually a sorting problem. Okay, so sorting is the classical case, and almost all of your data related problem you could break it down to the sorting. If you are not able to break it down to sorting, then you are really in a big soup. Those problems are very difficult to solve, even with the given technologies, whether it's Hadoop or anything. If you are not able to break down your problem into a sorting problem, then none of the existing tools will be able to help you delivering your results better. But sub problems of or auxiliary problems of your main problem might be improved with the sorting. Then let's take about joins. In SQL, when we join two tables, what exactly we are doing? This is a classic sorting problem where you have two sorted lists already and you are trying to join them. Okay, so you generally go with a merge sort kind of thing. So what I'm trying to say is all of these four cases of SQL is actually a sorting problem for you. Okay, and as an example of why people are working, even Google is every month, every year, they are struggling hard to improve their sorting. Okay, and nobody has been able to sort better than n log n unless they know more about data. If they don't know about data, if it's a generic problem, so generic solution, then nobody has been able to bring the sorting below n log n, below the order of n log n. N is number of record, and log is this is the order in which your sorting generally happen. I mean, but in case of big data, that n log n is not the answer, because there are lots of other things which come into play. Okay, where there is a merge, there is a sort happening in the disk, so the order is not really n log n. Recently Google was able to do a 10 petabyte. Petabyte is 1024 terabytes, as we told, in 6.5 hours, but they did it on 8,000 computers simultaneously and parallelly. So just to give you an idea, for us, if you can't imagine sorting 10 petabyte of data on a single computer, because the network itself will eat up your ears. I mean, at least 8,000 days you will take to sort this data. So what I have been trying to explain is, first problem we had was related to the storage, and second big data problem is related to the sorting and searching. Searching is generally based on sorting. When you're searching for any data, if you've already sorted the data, the searching becomes simple and easy. Okay, so these are two classic problems which any engineer would face while dealing with a large chunk of data in their problem. Why do we talk about big data now? First, there has been a connectivity of things. The data is increasing due to three aspects. First, connections between people and things. All the sensors are generating data. Your if you have got a new set of hardwares, they all generate data parallelly and update the central machines. In case of industries, factories, and everywhere, there is the Internet of Things where all of those machines are actually uh, blipping. They are giving the data out to a central device, which is detecting that whether the machine is performing good or not. So that is a connectivity between things. And then there is a connectivity between people using social networks. And there are smartphones which are generating, now generating data is so easy. Now everybody has a phone with a camera. People keep on capturing camera, okay, capturing photos. People keep on recording their calls. People keep track of call records all the time. And this is creating a lot of data to churn. So these are the three main factors. On top of it, Moore's law, which said that every 6 months we will have new set of devices, we will have new set of hardware which will be twice as fast as the previous one. So every 6 months we will be increasing the CPU with a 2x factor. The processor will become twice as faster every 6 months. Moore's law failed recently because the data bus became the bottleneck. We were not able to put more registers into the chip, and hence we are no longer making processors faster. Instead, what we are trying to do as of today, we are putting multiple processors together and seeing them multi-cores. Okay. So these are the reasons why big data is important as of today. Now, as an example of the big data, who are the people who are, handling the big data things? Are these? I would like to, you can ask your questions all the time. I would like to answer it at the end of every slide. So feel free to ask your questions. Do you have any questions as of now? Or should I move ahead? Hi, Amandeep. Could you please click on the live? You will come to the live session. You are still at least five slides behind. So whenever you get this message, please click on the live button. It's on the bottom of your screen. So probably either everybody has gone off to sleep, or I am a great I'm a great instructor that nobody has a question. Okay. So moving on, since nobody has a question, so do you guys have any questions? Should I move on? Um, Great. So let me give you a few examples of big data customers. So, so in very simple words, anybody having big enough data is a big data customer. Either they want to store it or they want to do all sorts of magic on top of it. Okay. So they are the big data customers, whether it's web and retailing, and then whether they are telecommunication guys. So these are the customers I have taken from Hadoop customers. Okay. So these are the Hadoop customers actually. So what do we do at web retailing? This is my personal aspect. We do build a great recommendation engine at Amazon where we display. You might also like it kind of things. And I have built recommendation engine as part of my InMobi career, where I was churning around 200 terabyte of data, which was 2 months data for recommendations. At Amazon, we built a lot of things on top of Hadoop and Mahat for the recommendation, which you see as recommendation at Amazon is generally a combination of all the Hadoop techniques and our proprietary techniques. So when you click on Amazon's product, you will see that you may also like this kind of product. People who like this product also like that product. So when you say people who like this also like this, it is called product to product recommendation. Okay. You may also like it is your personal recommendation based on your purchase history. And those are actually a big data problem because you have to churn so much of data in conjunction with other users that even even the data of 1 terabyte or 2 terabyte becomes very important to you. Okay, because the rate at which you have to generate recommendation may be at least once in 1 hour, because the behavior of people is changing so fast. They are buying new products and all. The other thing is ad targeting. Ad targeting is a very high paced game where there's a lot of real estate in the world who is trying to ask you for ad targeting. This I have done it in Mobi again. I have not done ad targeting at Amazon, but I have done ad targeting partially in case of in Mobi. So there's a huge demand. People, all the apps are asking you for ads, and you have to give the most relevant ads based on your inventory. That is also your big data problem. And then search quality. You have to build, you have to really work hard to improve your searching. Okay, search quality matters a lot, a lot. When you say pink tie or blue tie, let's say you say blue tie, it will not show you a book related to blue tie. It would to figure out that blue tie you are looking for in the products, and that is where we need to characterize all of our keywords and characterize all of our data to give you a great solution. And that becomes that's a background churning where we try to figure out the meaning of each of the words and how do we characterize and which search to show at the top and which search to show at the bottom. And it becomes a very difficult problem if you have millions and billions of the product and keywords. And then there is a very important aspect, abuse and fraud detection. Not only click fraud, but lots of kinds of fraud there is that happens all the time. So if you talk about Google need to figure out when people click on ads, does this behavior means that there is a competitor who is clicking on your ads, or is it a genuine user who has clicked on your ads? So Google figures out using all those techniques. Similar other kinds of fraud detection is that all the people who are doing transaction with you need to be checked against a given database from the government. Okay, and these are billions of records from the government websites. So that's all that comes under anti-money laundering checks, and that also becomes a big data problem after you have lot of transactions. Similarly, you have telecommunications where they need to figure out the customer churn preventions. In case of telecommunications, there are millions of towers, millions of people are talking simultaneously, and you have lots of connections coming and going, and you need to figure out why customers are leaving you, why customers are sticking with you. All of this can be figured out because you already have the data about the user. So this becomes a huge big data problem. And then you can perform do a network of performance optimization. People are actually doing all of this already. So based on the behavior of people in your network, you can improve it. So similarly, so Gaurav's question is, let me answer Gaurav's question. How can we use it for customer churn prevention? So basically, if you are maintaining a history of the user, okay, history of the user as in how many times his call got disconnected in past, how many SMS did he send, okay, and what kind of behavior did he have before a customer left you. So you can draw a pattern and figure out why did people leave you. Okay. So you can always figure out the patterns. You can draw people on a two-dimensional graph based on various characteristics, and then you can use basically a sort of maybe a statistical analysis or a machine learning technique that this is my input, this is my user, and he left. This is my user, he hasn't left yet. He's with us for so much time. And when we say users, we characterize user with various parameters: the location, the last number of calls, the call duration, and all sorts of things. And that way you can figure out what exactly had happened if you have enough data. Okay, so before you start doing any kind of daydreaming about churning the data, you need to start storing all of this data. In case of InMobi, we were keeping track of which person across the globe is asking for which kind of ad. When you play an ad, play a game, we at InMobi shows an ad at the bottom of the game. Not only in movie shows, but there are a lot of other people. So Gaurav, was I able to answer your question? So had so at InMobi, at one point of time, we realized that instead of showing that ad, we can give the recommendation to the user that since you play these games, you might also enjoy this. So this became a pretty successful at InMobi. Why? Because we already had that record. We never deleted our ad server's Apache logs. We had the details in place that who is asking for what. We never deleted it. We kept it. We had around 2 years of data already in a Hadoop infrastructure. So before thinking about all of this, okay. So there are some questions I'm going to. So Bhagwat, you said, have you discussed this slide? Which slide are we talking about? Rakesh, please click on the live button. You are still 5 slides ago. So Anto's question is interesting. Anto says that all these problems are currently existing in the industry. How are they handling it? Handling it now? What makes big data difference here? So these problems are existing, right? Now the thing is, lots of these people are not really doing it. Lots of companies are not actually churning their data, and most of them are deleting their past data. Take the case of your bank. Bank does not give you the bank statement beyond few years. I could not get beyond 5 years. Okay. So I mean, either they are, I don't know what they are doing with the data, but they are not able to use it as of now. Okay. With the traditional tool, the data becomes a burden rather than a tool. Data becomes very insightful tool to you if you have an infrastructure to store and process it. And lots of these players in telecommunication as well as retailing are not able to do it. Few years back, before the big data and everything became public and popular, startups used to die the moment there was a traffic. Okay. So uh, now the tools are there. Earlier the tools were not there, and people are not we are not really solving these problems. Lot of people do not solve these problems. And that's what now these organizations who are telecommunications, they have woken up. People like Target, they have started becoming aware that they could convert their all of they could gather more and more data and increase their performance by doing an analysis on such a large data. And data is not a burden, data is an insight. Now people are awakening to it, and thanks to the term big data, that people are becoming aware of it, making a decision that they want the data, they want to store the data. Instead of thinking of data as a burden, they are thinking of data as a insight and a future strategy. Okay, so that's what is the big data playing a role here. Okay, these problems are existing and can be solved using big data. Hi Prasad, you are still 5 slides back. Whenever you hear this, please click on the live button, come to the live. Okay, does it make sense to you? And similarly, you can also have a call record analysis. Okay, call record analysis as in which which part of the country or which city, what kind of people are able to basically, I mean, are calling at what time, what will be the best offer for them. Okay, the way Google figured out how to detect spam, how to label your messages, these telecommunication companies can do a lot and can help you in innumerable ways by churning the data if they wish to. Okay, they can improve their experience if they start solving this. So lots of companies have already moved. These are the case studies, these are the people who are using already. Okay, they have started using already. Some of the players are entering into the market. Some people have set an example that we can do solve these kind of problems, while other people are moving to it. Okay, similarly, there are organizations such as government's fraud detection, and we had Aadhaar card, which was based on a cloud computing environment, a big data problem. They had their Hadoop cluster. They're using it for all sorts of things. Similarly, there was a recent case study in which how a healthcare used big data to solve gene sequencing. Gene sequencing is a huge problem in computer science, and the main problem was how do we estimate it? How do we do all sorts of magic with the data? Is there any characteristic of the problems that makes it a feasible big data problem. Okay, so I mean, so Bhagwat's question is that what are the characteristics of problems that make it a feasible big data problem? The first characteristic is that it is a big data. Big data as in you are not able to process using a single computer. Either your network bandwidth or hard disk or RAM or the processor is becoming a bottleneck. Okay. Okay. Even if in certain cases, so his second follow-up question is just a huge amount of data does not seem like a qualifier. Yes. So as I said, that let's say you have to do a map search of a billion people. Billion means 10 to the power 9. So one and zeros, 9 zeros. So you have these many people and you have to figure out a pattern. You have to do a searching between these people. Okay. Although, had you been doing a simple sorting of these billion people, it could have been possible with a single machine. But if you are traversing a map or you are comparing one to five, I mean, you are doing all sorts of magic where you're you require more processing, more than sorting or more than any other thing. You might require multiple computers to process it. So the moment you hit a bottleneck and you think that you can divide the data across multiple machines, then and you hit a bottleneck that your single machine is not able to use it, that is generally a sign that you might have to opt for a solution which require multiple machines simultaneously and is a big data problem. Right, Bhagwat. So was I able to answer your question, Bhagwat? So in healthcare and life sciences, there are lots and lots of innovation happening, and lots of companies are adopting to it. Every day, there is a new research, and thanks to the big data tools and technologies, that some of the organizations have adopted to it, and lots of people are rushing to it. The problem is there is a demand and supply. These are tools, good enough tools, not really a great. Maybe tomorrow we have a better tool coming into the market, but there's a lot of talent or skill set which is required in the industry right now, which is missing. And since lots of people do not know about tools and do not understand why big data is a problem or how a data is useful, they they are not starting to store data. They are not building an infrastructure to the data. And that's where a skill or the knowledge plays a role. The moment you realize that it's not a big deal to store 100 terabyte of data, you will you will start storing the data rather than throwing it away. Okay, so that is what is lacking, and that's why there is a huge demand of people in the industry as of today. So anybody else has a question right now? So people, I mean, I think everybody has got a answer. I've been able to answer everybody's questions. So before I move forward, if you have any questions, let me know. Rakesh, whenever you receive this message, you click on the live button. You are still on an older slide, okay? And maybe it's okay, you continue. The only thing is you'll miss out on questions. Great. So I'm moving on. I'm moving on. So then other problems which we are trying to solve in healthcare, if you go on to the recent case studies, people have actually predicted that by analyzing a lot of data parallelly, they are able to come up with a lot of improvements in healthcare as well as drug safety. Because in drug safety, you have lots of parameters, geographies, and you have a lot of experimentations going on, and you have results of all of these everyday results every month, and you have this huge data which need to be analyzed. Okay, the data might be in gigabytes, but the way you have to analyze requires it to be divided on multiple computers, and that makes it a huge data problem, a big data problem. Now there are this ugly slide we have where there are so many people across the world are using it. These just few examples I've taken from Hadoop. So these are basically not really a big data consumers. These are basically Hadoop consumers. Okay. Okay. So Asan says that how does big data deals with network issues? A very quick answer is by not sending the data to the code, by sending code to the data. That is the quickest answer I can get you. But just hold on for a minute and I'll be able to answer your question. Okay. So basically by sending the code to the data rather than sending data to the code, it improves the network efficiency a great. Okay. And that's how most of these big data solutions help you. So Bhagwat is asking any links to read about interesting problems people are solving with big data. So that's a very interesting thing. I would suggest that you go to a website called Kaggle. I will type it here. It's called kaggle.com. You will see a lot of interesting problems which you could actually try it out. Okay. And also stay tuned with the Hot and Works website. I keep following a lot of people on Twitter who are data scientists. They are trying to solve really interesting problems, and it is interesting to see how many ways people can predict lot of things. The way at one time we were running a project where what we did was we were capturing the thumb size of all the people who are using our app. Okay, the way they are playing a particular game. So we were capturing that thumb size, how many pixels a thumb is touching, and based on that, we were trying to predict the age of the person. Okay, so these are the kind of problems which you would require a lot of data as well as a lot of churning of the data. You will have to correlate, plot a graph on it, all sorts of machine learning you might have to do. So all of this requires you to distribute computing onto multiple machines, thousands of computers parallelly to solve the problem in time. So you could go to kaggle.com and that would answer you. So I've typed at this corner, you can see this is the one I'm talking about, kaggle.com. Okay, and then you can go around it and see. Okay, Bhagwat, was I able to answer your question? So again, Prasad is asking the same question: how big data solves the limitation of network bandwidth? So first, the data is distributed. Okay, so there is not a single cable becomes your bottleneck, or single network interface does not become your bottleneck. Second, all these big data solutions, what they do is they have come up with something like a map reduce or some a programming paradigm by which the code goes to the data rather than data goes to the code. Okay, because your code is generally very small and data is too huge, so it's very efficient to send the code to the data rather than data to the code. So the transfer of your network becomes really smooth. Anybody else has a question? I was actually expecting a lot of question from you guys. Okay, okay, I've got a great question from Anto Alex. He's saying that could you simplify a difference between data warehouse and big data? Anybody for this answer? Can anybody else answer this? This is a very interesting question. So nobody else is taking up this question. Great. Let me answer it. Let me try to answer this question. So what exactly do we do in data warehousing? We figure out what are the dimensions or the data cubes we require more frequently, what is the data we require less frequently, and and what is the period of time the data is important to us. But the churning of the data always happens on a singular machine. Okay, when you are churning a result set or looking up a result set, it always and generally happens on a singular machine. So first, what you're trying to do is you are trying to slice your data. Okay, I got some answers. So Isan says that data warehouse, one kind of data only, while big data is variety. That's an interesting answer. Thank you, Isan. Maybe big data is used for real time and data warehouses. That's also a good answer. But both big data is used for both kind of problems, real time as well as batch processing. Hadoop was mostly focused till now on batch processing and recently moved on to becoming the real-time solutions. Okay. Yeah. So Bhagavat has also given an answer saying structured and unstructured. And in case of data warehousing, most of the case when we are creating dimensions and cubes and all sorts of basically a way to look up the important data faster was a pre-computed things, a set of smaller data. I mean, when we talked about data warehouses, we never talked about petabytes of data. We never talked about terabytes of data. We always talked about gigabytes of data. Okay, 100 gigabytes, 200, 500 gigabytes, that kind of data. Okay, so these are the first, these are the few differences. First difference is that in case of data warehouses, the data was smaller as compared to now what we talk about. Second, the data if either we create, I mean, out of the whole data which was bigger, we focused on a smaller subset of the data, or we created insights on top of the older data, bigger data, and focused on that smaller part. So we were still churning a smaller data. Third, the data in case of data warehousing was not real time. It was mostly batch processed. Fourth, in case of data warehousing, we never dealt with unstructured data such as images and maps and photos and the videos. And that's what differentiates the data warehousing from the big data solutions. So hope I am able to answer your question. These were very interesting question. So I would love to see more similar questions. If you have any question, just let me know. I've got a great class today and a great set of questions. Okay, okay. So I should proceed. Should I proceed, guys? So Gaurav is saying data warehouses is mainly for OLTP for decent size of data, but big data is mainly for OLTP for large data. OLAP. Yeah, I mean nowadays people are actually moving for the yeah. So when we talk about transactional data, we never talk about big data actually. So most of the data solutions do not focus on transactions. Okay. We do not focus on the transactions because whenever we talk about transactions, it becomes impossible to do that on multiple machines simultaneously. Yeah, you're right, Gaurav. Thank you. So one biggest difference is OLTP and OLAP. Yes, most of the big data solutions do not have the characteristic of a transaction system. So Suman's question is that saw few articles and blogs talking about fast data. Can you tell how is it different from big data? So probably I have not seen those articles yet, or maybe I am reading different kind of magazines. So so OLTP, Bhagwati, basically, I don't know much about fast data. It must be a new term coined by somebody. Like Google coined a term called obscenely used data. Okay, that went for some time. So fast data is probably the reason was that till date Hadoop was mostly used for batch processing. In case of batch processing, most of the data, most of the result people were expecting at a later point of time, not in the real time. So probably recently after Hadoop launched something called Apache Spark. Okay, maybe they started calling it faster. Maybe I'll have to do a research and then get back to you. If you drop me an email, I'll respond to you. Or maybe in my second class, I'll discuss this. Okay, I'll go about this. So basically, what people are talking about these days is that, I mean, I'll have to go through what do they mean by fast data. But the recent update from this industry is that earlier, most of the Hadoop and technologies like HDFS and everything was based on the batch processing psyche. Everybody was thinking in terms of batch processing. And recently, Apache launched a great project called Apache Spark, which is focused as well as Apache came up with a couple of people came up with a yarn architecture for Apache Hadoop, which made it possible to use Hadoop in case of a real-time data analysis. And that's what might be termed as fast data. I'll have to do a research, but that's the trend which is going on. So Bhagwat is asking what is OLTP and what is OLAP. So OLTP we all know, right? Okay. So OLTP is online transaction processing, whereby when I mean when you have a large set of queries coming for uh, real time transaction system, that is called OLTP, and OLAP is online analytical processing. So what we do is that we take a data, we characterize data with various set of indexes and dimensions, and when people ask for that data based on those dimensions, we return that data. You can imagine online analytic processing as a data which has been indexed on multiple set of dimensions which you can very quickly query, and this lies under OLAP and OLTP. This is a huge data warehousing terminology. So hope I am able to explain to you the meaning of OLTP and OLAP. And personally, I have not worked much on OLAP and OLTP, so I cannot give you an example of my real life. Okay. I worked on big data using, I mean, not very big data. I've worked on say 100 GB of my MS SQL database, which was nothing. Okay, and I'd never worked on handling kind of OLTP or OLAP. I've just read it here and there. So, do you have any questions right now for me? Should I carry on? Now, so should we take a 10 minutes break? Okay. If you are guys okay with it, then we can, take a little bigger break and come back after say uh, at 10:20. No, 10:20, a little more than that. So say let's take a break of 10 minutes and come back at 10:25. Okay. After the break, we'll be talking about Hadoop, the architecture of Hadoop. The second half is going to be little stronger. This was a general talk. So second half is going to be little difficult. So have good coffee. So let's meet at 10:25 and then discuss it further. Okay. Yes. Thank you, Suksavat. Okay, let's have a break and then come back in 10 minutes and have a good coffee because second half is going to be a little difficult. Hi guys, I'm back. Hi. So before the break, we talked about what is big data, who are the people using it. Okay, so before I go forward, I should answer Suman's question. He says that is big data mature? Okay, that is in terms of Gartner hypercycle. Also, is it still evolving to maturity? So your question basically is, are big data solutions mature enough? Or are big data tools mature enough for the enterprises and organizations? The answer is yes, because there are lots of people already using it. Okay. And I'm not sure Gartner hypercycle has included it or not. Maybe they might have included already. I just have to look it back. And in terms of using, let me give you a couple of examples. So when we talk about big data mature or not, let's just stick to a big data solution called Hadoop. Is it mature or not? So almost every player in industry is using big data. Okay, big data solution like Hadoop. So everybody in the industry is already using it. Okay, and they're using it for a very important usage, and they are able to do it successfully. Okay, and it has been quite some time since it was invented. Hadoop and HDFS and MapReduce was invented. So it is quite mature and it is quite solves problems of lots of people across industry. Okay, great, great. So that is my answer. So I mean, I'm not sure about whether Gartner has included it or not, but it is so mature that even at Amazon we are using it for our lots of processing. And finally, Google has also accepted Hadoop as a mature solution, and they have started providing hosting of it. Okay, so it's very mature and it's production ready, and there's a great support. I'll come back to all the things later. Now, Sukhsavat says, my idea, old concept, transactional DB, ETL, then data warehouses, and then BI, or analytic reports, big data concepts. Yes, yes. All right. And the big data concept is, old concept was, there was a transactional DB, and yes, that's a very interesting analogy. I think I should make a note of it. So there was a transaction DB, then we moved to the ETL, middle tier, then data warehouses, then business intelligence. Okay, called called analytics reporting. Nice, thank you. And big data concepts evolved in this manner. There was a transaction database, terabyte or PB of data, unstructured data. It's not actually a transactional DB. Generally, we consider in case of big data mostly non-transactionals. Okay, but it's definitely terabyte, petabytes, exabytes, or whatever form of data. Structured or unstructured data. Then middle tier, which converts this, and then yeah. So yes. So I mean there are solutions. So what you do is you combine both the things, data warehousing as well as your normal processing. You combine your both the aspects, whether middle tier, I mean whether data warehouse or the big data, you generally intend to combine both the solutions to give the end results. Okay, both have their own benefits. Good, thank you, Sukhsav. Let's just move on. Great, great. We have got a great set of audience today, and a great set of questions are coming in. So now let's move on to what is Hadoop. Hadoop is this cute little toy elephant, and that is how the name was given to it. So there's a toy elephant whose name was Hadoop. The founder of this Hadoop, his kid was playing with that, so he kept it Hadoop. Then, there was a guy called Dog Cutting at Yahoo who wanted to build a search engine similar to Google. So it was an open source project called Nudge. So he started the work, and then he was facing a lot of difficulty, and that's when then Google published Google file system paper as well as MapReduce paper. So based on that, Dog Cutting started working on Hadoop, which was the implementation of those two papers. And came along Mike Caffarella, and then they built this powerful tool for the consumption of the for the whole world. It's a framework to handle big data. It has many components which help in big data, and it has become a Hadoop has become an umbrella term nowadays. But I'll come back to the various components again. It is open source, and that is the power of Hadoop. Okay, it is completely open source. Had it not been open source, had it been proprietary, probably I wouldn't have been teaching it. Okay, so the concept of open source has propagated Hadoop so much, similar to Linux, that the adoption amongst organizations have grown really huge. And apart from being open source, it is well supported. Unlike lots of open source projects, Hadoop is well supported by couple of companies such as Hortonworks, Cloudera, and there are a couple of more players who give the support for Hadoop. Okay, so that is the scope. Those are the reasons why Hadoop is so popular. Second, it's quite powerful and popular. And what brings open source? What is the benefit of having open source? So the documentation, everything is available in multiple languages. Lots of people contribute to the same project. And then if you have a bug, you can go ahead and fix it. Okay. And that gives a lot less inertia to use the product. So that one, if somebody asks me why Hadoop, why not some other solution, a simple reason would be open source and a great stable product. And it is very reliable, scalable, in the sense that today you have 1,000 computers, tomorrow you might have 2,000. It's quite simple to scale those up because those were the design objectives of Hadoop. And this is Hadoop is an umbrella term to how for all the components now which are under the umbrella of Hadoop, Apache Hadoop, which are used for distributed computing. Okay, and then it is written in Java. The objective was that since we are going to utilize the all kinds of devices to run your jobs, it might be Windows, it might be Linux, it might be Intel processor, it might be some Motorola processor or whatever. Okay, it should run on all of those, and that could be possible only if it is written in Java, because Java JVM is available for almost all the hardware on this planet. So it was written in Java purposefully for that. Okay. So these are the few characteristics of Hadoop. Okay. Now let's talk about the core components of Hadoop. What are the core components of Hadoop? First is a file system and second is a compute engine. And third is the utilities which have nothing to do with you. These are the utilities being used by HDFS and MapReduce engine and common set of commands which help you interact with these two systems. Okay, so core of the Hadoop is actually from a user's perspective these two things. First one is a HDFS, which is nothing but a distributed file system. And why it is called distributed? Because you could combine as many as hard disk or network together to store your files. Okay. And similarly, we have MapReduce engine. What it does is it does the processing for you. You write your logic, hand over to MapReduce engine. It will execute on multiple machines together and give it back to you. Now, as I gave you main two problems, first was storage and other was processing. These two were the core components, are the core components of Hadoop for those two problems. First one is for storage and second one is for computing, for doing the processing. Okay, okay. So Bhagwat's question is, does it break the data? How does it understand the format? The thing is, it doesn't need to understand the format. Okay, it just breaks it with a a size of the data, a chunk, and then stores it in multiple places, and you look at it as a single file. Okay. So we will be able to answer these questions better when we look at the architecture. So before I move on to architecture, I think you will have more questions. So when we talk about the structure, so we told about two things. First is HDFS, which is where you store your files, and then MapReduce engine, which is how you compute or you do the computation on top of Hadoop. In case of MapReduce engine, you write your logic in terms of map and reduce and hand it over to Hadoop, which will execute it on multiple machines parallelly. So the code is going to the data and then it's getting executed there on that data and you are getting the results back. So these are the, in very, very simple words, these are the two basic components. Now let's have a look at the component architecture. So the base of whole game is this blue guy, which is HDFS. Everybody stores the data there and reads from there. Then you have MapReduce engine. So MapReduce guy basically reads the data from HDFS, saves it back, and does the computation. So it executes all of your logic in terms of piece of code called map and reduce, which you will write or any other tool will do for you. Then we have HBase. HBase is nothing but a NoSQL database. So HBase is nothing but a NoSQL database. NoSQL, what does the NoSQL means? We will cover this in the third or fourth session, but I'll just give you a brief of what exactly is NoSQL. Okay. A NoSQL is a database which is distributed and which cannot have a transactional properties. Okay. But it is very, very great for giving you a good availability because your data is stored on multiple machines and you can stream the data from multiple machines at the same time. So those kind of databases where the data is stored in key and value pairs, okay, are generally called NoSQL. These databases inherently, all of these databases have to have a key. On the basis of the key, the data is divided amongst multiple machines. So you can always imagine a NoSQL database like HBase as similar to your database, similar to your existing database, just that every table is supposed to have a key. First column has to be a key, which is a unique, and there are columns, and these columns can vary between the rows. First row can have 3 set of columns and second can have the 5. But in case of HBase, you will think that it's similar to your RDBMS. You will think that, oh, it's a complete table structure, but that's not the case. Okay, so every NoSQL has these kind of properties, and HBase is one of those. HBase is a tabular form of NoSQL databases. NoSQL means it doesn't have the SQL kind of properties. Okay, it cannot guarantee you the ACID properties because since it's storing the data on multiple machines simultaneously, it is impossible to give a guarantee of a transaction, because if it gives the guarantee of the transaction, it will not be able to give you a very high speed. See, one guy is writing to one column and other guy is trying to read from the similar column. Now if the first one is trying to put a lock on it and trying to ensure all the transaction properties, then it will hit the performance very bad. So most of the NoSQL, almost all of the NoSQL cannot give you a guarantee of transaction, and that is what differentiates a NoSQL with a normal database. And this is done in favor of performance and availability. Okay, we forego the ACID properties in favor of performance and ability to handle a lot of data or big data at the same time. Okay, so that is called a NoSQL database, and HBase is one such NoSQL database which has an ability to store the data all across. Okay, and HBase favors availability over consistency. And also the HDFS is write ahead, as in you do not change the file. If you are changing the file, you are actually creating a new file. Okay. We'll talk about that again and we'll dive into the details more and more. So, and similarly, we have a MapReduce engine. MapReduce, how does it work is you write your map, so the code for the map is written by you, okay, as well as you write a piece of code called reduce. So there are two pieces of code. One is a function called map and other is function called reduce, and you put them into a single jar, or you combine them whatsoever manner and hand it over to the MapReduce engine. It executes that parallelly on multiple machines and gives you the result. Okay, so the job of the map is to, when you are giving output of the map, it should be in the form of key and value. Okay, and for the same key, all the values associated, if there are multiple records having the same key, all the values will be aggregated together by Hadoop for you and hand it over to reduce. Okay, so your map code will take a row of the data which is handed over by the Hadoop and convert it into key value pair. And Hadoop will combine all the values related to the same key. If you have multiple rows with the same key, it will combine them together and hand it over this array of values to your reduce logic. So this way, you can think of map and reduce as two parts of group by statement. Okay, group by statement of SQL has two parts. First one is The group by statement, how do you do? Group by A comma B, meaning I want to group by these columns in this order. And then for rest of the columns, I want to apply this aggregation. So these are two phases. First, selection of the ID in the group by clause. And then you have the logic which combines the values of these IDs together. This is the format of the group by clause. And you can think of map as the first part of the group by, where you are defining your IDs on which you want to group by. And that is the key in case of map logic. So you say, hey, this is my data. I want to in your map you say this is my ID and this is my value, meaning I want to group by this ID. And then while in aggregation you say all the values for this ID need to be combined together. And this is the way I want to do an average, I want to do a summation, I want to do comma separate aggregation, whatever wish you want to do, you will write that in your reduce logic. So the benefit of map and reduce is that you are able to do a sorting and you are able to break your problem into a sorting problem, and which Hadoop is solving for you. Under the hood, it is doing all of it for you. All you did is define an ID for your data and define the aggregation logic for your data. And based on that, you are able to churn a lot of data parallelly and simultaneously and combine it together and get the right results. Okay, you do not have to worry about how these keys will be sorted. You are just spitting out the keys in your map logic. You are not worried about how are they going to be sorted. That's the job of Hadoop for you, and that's the job of map reduce component of Hadoop for you. Okay, so these are the two components we will discuss in detail as we go forward. And for MapReduce, do not panic if you did not get anything. I am going to take 1.5 class, meaning 4.5 hours class, just to give you a good hands-on experience on how to convert any logic into maps and reduces. And this is going to be a really good exercise for you, no matter what kind of programming environment you had in past. I'll make sure that you learn how to convert any problem into a map reduces problem. And that is one of the very, very important part of big data. You face a big data problem, you will start thinking that, hey, how will I convert this into my map reduces? And that will be an interesting part. A problem as simple as finding palindromes in 500 terabytes of data becomes extremely impossible to solve using existing tools. Or you want to find out anagrams, which are the words in Wikipedia which are anagrams of each other. Okay, if you have to do this, how will you do that using map reduces? Okay, so that is a psychology which you need to build. When you want to solve a big data problem, you need to be able to convert your problems into map and reduce or other tools or the languages which are there. This technology stack. I'll explain to you more about other technology stack. Okay, great. I have got some question. I will answer one by one. So Bhagwat is asking, does the map automatically sort the values? No. What happens is your code, which is part of the map, just says this is my key and this is my value. This is my key, this is my value. So all of the data which has been fed to your program line by line, it will spit out key and value for that. Okay, so Hadoop will call your map logic for each line in the input text. Okay, and your logic will convert that line into key and value. Right? You will say, out of this line, let's say that this whole line I break by spaces and put every word as the key while one at the end of it. Okay, now these become your so many keys out of the single line. Now this infrastructure of Hadoop, when it gets these key values from all of these Hadoop, all of your map reduces, it will sort them. It will sort them and merge them such that all the values with respect to a single key come together, and this array or the collection or set of values is fed to your reduce program. So id comma set of your values goes to the reduce program, and then it will do that job. So this aggregation of IDs or of values for an ID is done by Hadoop for you. And as I said, most of the problems are sorting problems. So this aggregation of key of the values for a same key together is the job of sorting which Hadoop performs for you. Okay, and this will be done automatically by the platform. Okay, by the platform, by Hadoop for you. So if I have an image file, it stores it in parts. If I have an image file, it stores it in parts. That seems to be very interesting how it does that. So basically image file, what it will do is basically it doesn't matter for HDFS. Actually it doesn't matter whether it's binary or plain text. All it does is at that ith byte, it will just slice the file and put it here and there. Okay, now the problem occurs that how are you going to churn it, and that's where a lot of mechanisms come into place. Okay, so you generally try to keep your images together at various places, and when you are writing your logic, you define those things. Okay, so we will talk about it when we go into the, this is a little difficult to answer right away because it would require a little background on HDFS. Okay, so I hope I'm able to explain a basic infrastructure of MapReduce. I will dive into details of MapReduce because that is the heart of the game. You need to understand the psyche. You need to, because MapReduce says that you need to break down your problems. Any problem you try to solve, you need to break it down in terms of maps and reduces. Unless you understand the concept of MapReduces, most of the tools will look very inefficient to you. Okay, now let's move on to the next stage. Now the next set of tools which are not core part of Hadoop, first is Hive. Hive is a very beautiful thing which happened to Hadoop, which helped lot of developers to adopt Hadoop quickly because it gave a SQL interface. This SQL interface is select XYZ from this table where this is that. Actually converts the whole query in terms of map and reduces and get it executed over HDFS. Okay, and that gets when Hive asks this to HBase, and HBase does that for you. Okay, so HBase internally also uses MapReduce and gives you the right results, and that is the beauty of Hive. Hive gives you a SQL interface to query your HBase. Also, the other very important idea to remember in mind is, it is very frequently asked questions by people that if we have multiple kind of databases in our organization, say for example you are having MySQL, MS SQL, Oracle, or object oriented databases such as MongoDB, which are document oriented, and then you have Object4j, which are maps. So Hive has been able to develop drivers so that you can query all of these databases together. Okay, and that is the beauty of Hive. So you can query MongoDB from Hive, combine that data with your table, join that data, staying in your HBase and get the results. That is where your Hive comes into picture. Okay. Now there is something called pig. So when I talked about SQL, I was saying that while SQL is processing your query, while Hive is processing your SQL query, it's converting into maps and reduces. Okay, so your queries might become a little inefficient in terms of when you are writing in Hive, because Hive was because SQL was not designed for a distributed system. SQL was designed keeping in mind tabular systems where you can join together things very quickly. So the people like people I will name it. It's a person from if you know Kernighan, Brian Kernighan from C background. He was the one who came up with this new language on which the Pig Latin has been written, which makes it very easy to query to convert your query into map reduces. So Pig Latin is a new kind of language which is sort of set based, where you say you keep on giving names to each of your data sets in terms of tuple, and if you remember tuple algebra, so it is sort of that purest form of tuple algebra where you define set and then query and then all that sort of thing, and which is far efficient than writing your queries in SQL for and running it on Hive. If you write a pig Latin script and run it on pig, it's pretty fast. The translation from your Pig Latin. Pig Latin is basically that language, we call it Pig Latin. So the Pig Latin gets converted into MapReduce, and the MapReduces are far more faster than your general SQL. And that is the beauty of using Pig Latin, because this is designed in the designed keeping in mind the MapReduces, keeping in mind the distributed architecture of your big data solution. So Pig Latin was designed bottom up, thinking big data in mind or distributed computing in mind. Okay, and now on top of that sits your workflow system, where which you can combine your Hive, Pig Latin and map reduces in a single workflow, saying the result of this guy, this computation, go to my SQL query, and you can combine them together and run it uh, as a pipeline. Okay, so that is the role of workflow system. Earlier we had Azkaban, now we have Uzi, and these are very beautiful workflow systems which help you do your batch processing and combine multiple scripts or multiple components together to do your job. Okay, so that is the role of Uzi. Wow, I got so many interesting questions. Oh, so thank you, Bhagwat, for answering the question. Let me repeat. In distributed environment, if any node fails, my data will be lost. What is the recovery for that? That's the Alex's question. That's an interesting question. So in the distributed environment, if node fails, so the way the replication happens, I'll come back to this. I'll come back to this. Give me a few minutes. And yeah. So thank you, Bhagwat, for answering. The concept is taken care by replications, and I think I can't undo the selection. I've already selected the question. Great. Oh, Alex has already said. Okay. So Bhagwat is saying, can you use Pig Latin in any language like in C++. Of course, of course, of course. So you write your query the way you used to write your SQL query and then call the SQL server. Similarly, you write your piglatin and connect to pig and hand over that query and it will give back you the results. There are proper drivers for that. Okay, so it's exactly like that. Okay, so I hope I answered your question, Bhagwat. Great, great. So we talked about pigletin, we talked about workflow. Now there is this magic which happened. So people came up with something like Mahat. Mahat is basically a statistical and machine learning platform which does the magic for you. There are lots of algorithms people have written in Mahat and which are part of Mahat. Okay, what exactly is Mahat? Mahat is the guy who drives an elephant. And in this case, Mahat is the guy who drives the elephant crazy. Okay. And I mean, it's actually for lots of us, Mahat does a heavy lifting for us. Say, in case of a recommendation engine which I wrote, all I had to do was I had to give file, three column file as in first column was as in a plain text file, these three values were tab separated and two records were new line separated, and first first column contained the product ID, second column first column contained user ID, second column contained product ID and how much they liked it. So I gave a data of my current users product ratings. This user likes this product this much, and if and Mahat gave me back what this guy will like how much, and it was as simple as that. All I have to tell Mahat, give me the recommendation for these users who like this product this much, and Mahat gave me a response back, this guy would like this product this much. It is as simple as that. So whatever data you have churned in the format of three columns, user, product, and rating, Mahat gave you back a great and beautiful answer of recommendation in a single shot. You did not have to write a single line of code. And this is probably one of the best results you can get. And Mahat provides you, this is just one tiny weeny bit of how people use Mahat. So there are so many people working on Mahat, providing so many algorithms and layer for Mahat for you, that it has become very simple to do machine learning using Mahat. All you have to define is, this is my training data, this is my result, and that's all. Okay, and that makes big data, the big data what people perceive. People perceive big data as the magic, and Mahat makes that magic. Okay, so we will discuss it briefly. We will discuss Mahat briefly. Rest will be up to you how to explore it. You dive deep. We will show you a couple of examples, how you run Mahat and all, what are the various algorithms in later point of time, probably sixth session of Hadoop. So while lots of people get scared of when they hear machine learning, when they hear statistical analysis, but most of the heavy lifting of the industry of big data churning has been done by Mahat. Mahat is a simple library which takes input and gives you output, and it runs all of this logic on top of Hadoop. It converts all of its logic internally into sections of Hadoop. So most of this magic and most of this science and engineering happens over Mahat. Mahat has been the magic of the industry. Okay. So that's pretty much it. And then the users can interact with all of these components at various level. They can ask their code to interact, or they can interact. And then we have data import and data export, which is Flume and Scoop. Flume is for importing, exporting data to Hadoop file system using unstructured data such as videos, photos, maps, plain text, and binary files. While Scoop is for structured data in form of tables or XMLs. So, so this is the ecosystem of Hadoop. So the common denominator of all the game is HDFS. Then for rest of the people it's MapReduce, and then HBase. HBase is a combination of both, and then Hive who depends on MapReduce and HBase. Then we have Pig, which purely depends on MapReduce. We have Mahout, which gives you great machine learning and statistical algorithms, while keeping all of the science hidden, abstracted out for you. If you wish, you could write your own logic as well and combine it together with your Mahout script, and you can get a very beautiful results. I was talking about, you know, the thumb size and the relation between the age. We were doing it on top of Mahout, and we were doing is we're saying this is my training data and this is my result, and Mahout was giving us a really beautiful output. So while for 99% of the people that is magic, for you it's a simple engineering problem, and thanks to Hadoop to do that, thanks to Hadoop and Mahout to do that. And that is why, if you understand this stack of components, you will be able to solve most of the big data problems which exist as of today. And you can, come up with your better solutions. Does your data have a relation between products? Right. That's another kind of recommendation. Okay. So that also, if you can give a product to product relation, basically you did not have to give this relation to Hadoop. You did not have to give this relation between products to Hadoop, because to Mahout. Mahout automatically figured that out. Mahout automatically clustered your similar users together and gave Bhagwat looks more like Gaurav based on these criterias, based on their common set of movies. These guys like similar kind of movies, so why don't we give a recommendation to each other? And that is very beautifully done by a couple of very innovative algorithms at Mahout. Okay. So Pig works with databases only. Not really. Not really. So Pig is basically a way of saying that I am little lazy. I do not want to write my code in Java or JavaScript. Okay. And it makes it very easy to do your common jobs using by providing you a quick query language for similar to SQL. Okay. The difference between the way iterating over table and all this sort of thing. So every pig Latin or pig script gets converted into maps and reduces, so you don't have to write too much of code for that. Okay. And it is actually very simple to do it. I will explain to you in one of the classes. No worries. Now moving on. Okay, great. So Gaurav has got a great question. Can we use Mahout outside Hadoop? That is, can we use it as machine learning tool? And yes, you can. That is the part of Mahout, which is quite Mahout existed before Hadoop became so popular. I mean, in terms of various kinds of algorithms, these algorithms existed before that. Okay, and they used to run in terms of independent computer. But after Hadoop came, Mahat figured out that converting most of the logic into in terms of MapReduce will make everything very fast. So yes, you can use. I'm not sure how supported it is, but as far as I have read, Mahat, they claim that they support give you a command line, okay, a proper command line in which it will execute as if there is a single node. Okay, there is even if there is no Hadoop installed, it will work perfectly fine. Lots of people use uh, Mahat independently also. Bhagwat is asking, I want to use Piglatin in a pure C++ code that may work on images outside Hadoop. I want to use Piglatin in a pure C++ code that may work on images outside Hadoop. Is it possible? No, really, no, 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 no. So pig Latin would basically make sense only if you are using it, because pig Latin is nothing but saying map reduces in a simple form. Okay. So basically, it makes it easy, your life easy while you are writing code for Hadoop. Okay. So pig Latin does not make any sense outside Hadoop. Okay. Okay. I have got a lot to cover. So probably the class will stretch to 10, 11:40 because we had taken a 10 minutes break. Okay. I hope that is okay with you guys. Okay, great. So let's talk about core components. And so we talked about two parts of core components, HDFS and MapReduce. Okay, now HDFS distributes your data across nodes. It is fault tolerant, high throughput. It requires low cost hardware, and there is a name node which is like a manager or the bookkeeper which does your job. Similarly, in case of MapReduce, these are the two core components. First is storage, second is processing. MapReduce splits your task across processors as well as across, you can say, nodes. Okay, here we can also say nodes, and then the near the data, basically the code goes to the data rather than data coming to the code, and assembles the results and gives back. Self-healing in terms of, if one of the maps did not give, one of the machines did not give an answer, or while sorting, while we were ordering the data, one of the node goes down, we use the second another nodes to do the sorting for us. That is the magic of MapReduce system. And then we have clustered storage. Basically HDFS storage and job tracking. Okay. Let's talk about, let's just look at the HDFS first. Okay, let's just look at the HDFS first. Okay, so this is my HDFS. Yes, Pig simplifies the MapReduce design pattern. Thank you, Bhagwat. That is the answer. Okay, great. So when we talked about HDFS in very, very simple words so far, let me just dive into a detail a little bit. We have got 20 more minutes to do that. So I'll be slow, but I'll be try to explain each and everything. So how does it work? Say you have you have 5 computers. On 4 computers, you install Hadoop and mark them. You store Hadoop and then mark 4 of the computers as data nodes. Okay, just look at the bottom part of this slide. So you mark 4 of these computers as data nodes. The role of a data node is just to store data. Okay, and then 5th computer you mark as name node. The role of a name node is to provide you all the information about where is your data lying. So name node is more like a supervisor of a workshop, or name node is like a bookkeeper in the library, where which knows which file part is where. Okay, so name node is doing the keeping the metadata, such as what is the file name, which where all is it being stored, which part is on which machine, and what is the replication factor this file is trying to enforce. What does it mean by replication factor? Replication factor means I want to store 5 copies of this file. This particular file is very, very important to me. I want 5 copies of it, which means that even if there is a disaster and 4 of the node goes down, you still have your record. And that is the magic of your this cluster. So you have always have 5 copies. So the point is that now this name node is the guy who is doing a lot of magic for you. We will come back to this slide again and again. And HDFS was designed with hardware failures in mind. Why do we have this sort of architecture? Okay, where we have data nodes, these 4 data nodes, whereby basically on these data nodes we store our actual content, while name node is providing you an interface where to locate your data. So name node will split your data, put it on these systems, and split as well as make a copy of same file 4 times or 5 times based on what kind of replication are you asking for. If you are asking for, say you have a file and you are saying, hey, I just need a replication factor of 2, which means if this file is divided into 3 parts, these 3 parts will have one copy, so there will be total of 6 parts, and which will be stored on these machines. Okay, and when HDFS cluster is asking this name node for the the data, it will redirect the client. When the client is asking the name node, where is my file, give me this file, it will tell this part lies on that machine, this part lies on that machine, why don't you get from there? And then client will get it from there. And this problem of going to that file or this file is further simplified for you by HDFS file driver, who will do the job for you. While name node will say that your file is lying out there, you go there and don't talk to me. I mean, his role finishes when he redirects you to the each parts. Okay. So this sort of architecture is needed for the hardware failures, streaming data access. Since your parts are stored on each data node separately, if 5 people are asking for the same file, okay, so these 5 people will be redirected to different machines and they will get the data from there. Instead of one single machine getting loaded, these 5 clients are being redirected to multiple machines and the load is being shared. Okay, so this makes it possible to jump to a particular location without bothering other machines. So if you are jumping to, say, middle of the file, You can directly go to the third server rather than first or second, and that is the beauty of it. Streaming data access, as in you can stream data at a very fast rate because you have multiple machines serving the same data. You have PCs stored on multiple machines so that no single machine is the bottleneck. And then it is designed for large data sets. Large data set, because you have so many nodes which can have hundreds of hard disks connected with them, and gives you a large data set. Similar, a simple coherency model. Simple coherency as in the data which is closer to each other, which is to be generally computed each other, is getting stored in a nearby fashion. We also call this model as rack awareness. Okay. Now, the other assumption of HDFS is moving code is cheaper than data. And similarly, the other design goal of HDFS was to have portable. The portability should be there in case of Java. Because as I explained earlier, that you can host Hadoop in various machines parallelly and still have a single file system, right? And these machines, one can be Sun Solaris, other could be Mac, and third one could be Linux, and fourth one could be Windows, and so on. And that could be possible only if you have a virtual machine like Java in place. And that is the reason why HDFS was written in Java. Now this architecture should give you a very clear picture of what is happening. So this client came in and wanted to write. First it goes to the name node and says I want to write something. Okay. So name node makes a bookkeeping entry saying this guy wants to write this file, and this is the replication this guy is requesting for. And name node in turns redirects the client saying you should be storing this part on first machine, this part on my ith machine, and this part on my nth machine. Okay. And this is what bookkeeping does, and then redirects the client to go to those machines and write the data, and then give the confirmation back to the name node that he has successfully written the data. So that is the job of the name node. Okay. That is the job of the name node. And the client is actually reading and writing to the individual data nodes. Okay, so name node is also a machine or also a piece of software which is running on a machine, and you are interacting with it at a certain port. It is storing you the files and then redirecting you to the individual machines to write the data. And this redirection, do not think of that you will have to write your Java code in such a manner that it has to handle the response of name node and then go to the each of the racks and write the data. No, the driver, the HDFS driver which will be provided to you, does all of it for you. Client is sort of, you can say, HDFS client, which is provided by HDFS themselves. Okay, so you interact with the client to get your stuff. You do not have to go onto each machine to do all of this magic. Okay, so this is what it is. So you have rack 1, rack 2. Rack 1 is hosting these 3 machines on the left, and first machine is having 3 parts, second machine is having 2 parts, and third machine having other two parts. Similarly, rack 2 is having two machines. First machine is having some parts and second machine is having some other parts, and all of these five machines are called data nodes, and name node is just keeping track of all of this information. And name node basically keeps everything in the memory and keeps a backup using a secondary node that we will discuss in detail further. So this is what is the general architecture of HDFS is. Okay, so Alex is having a question saying, what happens when name node fails? Do we have backup for that? The standard Hadoop system did not have a backup for that. The only backup we had earlier was something called secondary node. A secondary node used to keep a snapshot of the information periodically. But recently, Hadoop has come up with the concept of snapshot node, or I mean a node which is sort of a backup node, which keeps a mirror image of name node. In case name node goes down, you will have to that backup node can come back. But in the standard Hadoop, earlier Hadoop systems, uh, there was no way to quickly restore it. Only thing we had was we can set up a secondary name node which will basically keep on taking the data and keep a snapshot of it. Keep a snapshot of it. Okay. And yeah, so the name node used to be a single point of failure in most of the Hadoop standard architecture. So interesting question. Ishan is saying that can't we use parity kind of thing here, because replication will require a lot of space and hardware storage. Okay, so let me explain to you this. Store is cheaper, space is cheaper if you can use commodity hardware. Okay, so if you are able to use commodity hardware, space is actually far cheaper than what it has been projected by other systems. Okay, so instead of buying a costlier hardware, you choose a cheaper hardware, but you do not worry about your extra storage space. Instead, you worry about your data. In case of parity, basically parity kind of thing, those systems are still very suitable for smaller data sets. They are not suitable for storing petabytes of data. Okay, so it is okay to go for a 2x kind of a space wastage. Okay, moreover, in any parity kind of system, those systems were built to make a check whether the data is not corrupted or not. Okay, they were not for really a reliable and replicable system. Here, in case your node fails, the data gets replicated again, so that you have still three copies. Say one node goes down and one piece of your file is only having a replication factor of 2, which can be further, will be automatically in its replication will be increased to the next machine. Those pieces will be replicated again. Whatever we have lost right now will be automatically come back, and that is the strength of a HDFS kind of file system. So any of this node, any of these green or yellow nodes, you see, these nodes go down. If any of these nodes containing these red rectangles in them, if they go down, the whole data which was inside them will be available on other nodes, and it will be quickly replicated at other places. And that is the beauty. That is the beauty of your this kind of system. Parity system will not do justice for your data redundancy and data backup and for handling failure. Now let's have a look at how does a file write look like. So name node is master of the system, maintains and manages the blocks which are present on data nodes. Data nodes are actually the slaves which store the actual data, does the all reading and writing for you. This is what goes on inside a file write or read. Okay, so the HDFS client, which is your command line, or the interface which is provided to you by Hadoop, either by the way of command line or by the way of a driver. He asks to create a file. Now that request goes to the name node. Name node creates, basically name nodes makes a note of the metadata, and then hands over the write to the data node. Now HDFS client will write to the data node and give back the results. Okay, and once it is done, it is informed to the name node, and name node makes an entry of it, and the HDFS client takes a note. Similarly, the data is also read from the same manner. HDFS client will ask, I need this file from this particular byte. I do not want it from the beginning, I want it somewhere in the midway. And name node will direct this guy, tell all of these pieces are available on these nodes, and you get it from there. And your HDFS client automatically start reading it for you and give it back to you. So Alex's question is, what kind of system requirement for name node and data node is? Interesting question. So for data node, it is very commodity hardware. Okay, whatever disk space you have an old computer, put it in the network. You have a old tablet, you can also put that into that if you can install Linux or virtual machine on it, Java virtual machine. Or you have a good server, you can put at a data node. So data node is more or less runs on almost all machines which can run JVM for you. But name node, since name node keeps all of this data in memory and gives you a really fast access to the files which you are looking for, name node would require a bigger RAM in case you, and if the RAM is smaller, say you have provided a 256 MB RAM, what it will do is it will make a bigger pieces of data so that the metadata is smaller in size. Okay, so those are the magics being done by name node, but as a practice you always keep a bigger server for name node and all smaller and commodity hardware for data node. So that is the kind of system requirement you have. For data node, any of the consumer devices is good, or I mean even those smaller machines you can use. While for name node you need to use a machine which is good RAM. There is no other requirement from any of these sides. And for your name node, prefer a machine which is 64-bit so that you have a bigger RAM utilization and bigger address space. Similarly, so metadata is in memory, and also there is a backup, and there is no generally demand of maintaining the metadata onto the disk as per certain computation. The only downside of having a smaller memory for name node is that it will start creating bigger block sizes automatically. And then what kind of metadata does the name node stores? Name node stores uh, basically in this format. You have a file xyz. So part 0 is on has a replication factor of 2 and is stored on machine number 1 and 3, while part 1 has replication factor of 3 and is stored on machine number 2, 4 and 5. And that's the kind of metadata it stores. Okay. The other thing is the transaction logs. When were the file created? When was the file deleted? When was it updated? Those kind of things are also stored on the name node itself. So before I move on, so I described you two things. One is name node and other is data node. So name node helps you with basically this is the guy who is doing a big bookkeeping for you, because HDFS has to split the files and put it on various nodes and replicate a file on various nodes, and name node helps you in that. Now you have something called a job tracker. Okay, this is the guy responsible to run your MapReduce task. Job tracker has been called Yarn after a little architecture revamp. Do not worry about that. We will discuss about it again in the classes. So job tracker's role is to provide you a way of interacting with the actual executors. So all the people who are trying to execute their MapReduce job, they interact with job tracker. Job tracker divides your jobs amongst task trackers based on what kind of PCs are available where. Okay, so let's say you had a file XYZ. Okay, you asked job tracker that these are my map reduces which are going to run, which are going to need XYZ as the input to map reduces. Now job tracker will figure out where is your file which is input, which you expect as input to your MapReduce or your execution logic. It will figure out where is it being stored used from the name node, and then only send map and reduces to those machines only where your file is actually stored. Okay, so that is the magic being performed by job tracker. So job tracker distributes your job amongst task trackers. Task trackers are running on each machines. This shows you a diagram where you have 5 machines. 4 of them are actually doing the job, and fifth one is doing your bookkeeping. So job tracker is doing the bookkeeping for you. You interact with job tracker and demand the result from the job tracker, while job tracker is handing over your task to each individual executor and submitting the solution back to the job tracker so that you can get the right results. So this screen gives you the answer of how is your job tracker architected. Okay, so job tracker's role is to get the work done by the task trackers. Okay, now this is how it looks like. User copies his file to HDFS and then also submits the job in form of a jar file. A jar is like a zip file in which you put your files together and makes a single file, and that also is put on the file system HDFS. Both input file as well as your code is located on HDFS. Now you inform this basically you inform this job tracker saying, hey, this is my job. Now execute it. Now job tracker does the split for you. Okay. Job tracker is going to split into small pieces. After you have submitted the job tracker has splitted that file, it splitted your logic across all these machines and created a queue, job queue, exactly the way a supervisor in a workshop keeps a slots that this or in a hotel you order a lot of things, okay, and there is an order book whereby you keep these slots and the order number. Similarly, job tracker creates this queue where it marks that this result is expected from these machines. This result is expected from these machines, and then combines that together and does the magic for you. So this is how a job tracker is doing the job for you, as you can see in this diagram. Okay. Similarly, a heartbeat is being used to check whether each of the task trackers have finished their job or are still running. If a task tracker goes down, the things which were assigned to that task tracker are assigned to somebody else containing the same data. And that is why we call it a self-healing system. Okay. So these heartbeats help job tracker to do a lot of magic for you, such as keeping track of which machine went down, which machine is still working. In case a machine is going down, whatever whatever task was given to that machine, we give it to somebody else. So that's pretty much from the job tracker side and the HDFS side. If you have any questions, please feel free to ask now. So I'm pretty much through the system. Now, as a second class, we generally give the assignments and we ask you to set up a Hadoop environment and we help you setting up your virtual machines. So this is a pre-work for the next class. In case you go for the full course, you can do that. So 13th will be the second class in which we will discuss the other things such as mentioned in this. We'll talk about Hadoop cluster setup and setting up your input output data. Okay. And this is pretty much, you can feel free to ask me the questions. Also, I'll be sending you a feedback questionnaire and you can go ahead and purchase the full course to attend the rest of the classes if you like the today's class. And this will basically the second class is going to happen on 13th July. If you like the course, if you purchase, you can attend the 13th class. Otherwise, it is okay. And in case of any further questions, feel free to talk to me on my phone number, which I have given the first slide. So this is my phone number at the bottom of the screen, as well as this is my email ID. Feel free to ask me. Okay. So the other thing I would be asking you is I'll be sending you a feedback form. Please fill that feedback form. Along with that, I'll be sending you the recordings of this class along with the presentation slides if you need it. Okay. And if you have any other questions, you can ask me. Okay. So guys, this is pretty much from my side. This is pretty much from my side. So feel free to ask me about the further classes and whatever questions you have. Okay. If you want to attend, you can go and you can go and enroll. I'll just share that with you guys. Okay. So you can go ahead and sign up. So if you go to knowbigdata.com, under Hadoop, you will have this enroll now button. You can go ahead and enroll now. The full course is 15,000 basically, and you have a discount till 9th of July. Okay. So once you click on enroll, you generally will see this screen. You can select your currency. If you don't like INR, you can select USD, and this is how it will happen. Yes, yes. So Isan is asking that could you explain the concept of yarn related to big data? So the task execution philosophy, which I just explained, has been fine-tuned in yarn. Yarn is nothing but a revamped uh, job executor philosophy. There is a little bit of change, but the general philosophy remains the same. Okay. So yeah. So the general assignment for today is uh, one there is a pre-work where I'll be listing down the various kinds of virtual machines for you. Okay, and we will also how to you will have to set up your Hadoop environment. We'll give you the instructions on how to set up the Hadoop environment for you, but we prefer that you generally use a virtual machine or any of our servers. We'll be setting up servers for you with the pre-default installation. In the beginning, we'll have only two or three machines, and then at the later point of time, when we are setting up the whole cluster, we'll provide you a complete cluster to test. So right now, all you have to do is you take up those virtual machines and set up your Hadoop environment, or or I would prefer that you start using our virtual machines so that right now you don't get stuck in installation problems. Once you get used to the cluster setup, then you can set up your own machines. Then we have a quiz in LMS which you have to finish to test your knowledge in today's session, and then see the assignment section on LMS for more information. So that is pretty much from my side. Okay. So basically, in case you have any doubts, feel free to ask me. Okay. And thank you very much for the class, for coming up. And I thoroughly enjoyed your questions, and it was a great session. It was a great session indeed. Okay then. Good night for people from India, and good. I don't know what time would it be in the Europe and other countries. So good night, guys. Thank you for coming, and I look forward to interact with you guys. And in case you have any questions, give me a buzz on the phone or in the on the email. You already must have got my email and phone number. So feel free to interact with me, and let's see how we can take it forward. Okay. We'll keep running these demo classes for other subjects which we are coming up with, such as data sciences and analytics in R, business analytics in R. So stay tuned. In case this course was not for you, feel free to join in that. Thank you, Prasad. Thank you for coming. It was great. I thoroughly enjoyed your questions. Good night for you. I don't know who all are there as a viewer, so I cannot say goodbye to each one. So I will be sending you the link to how do you buy it of the full course, as well as please feel free to give me the response of feedback on this class. Okay. Thank you, Alex. It was nice to see you, and stay in touch. I know that I mean you may not like this particular timing. In case some other timing works for you, you can sign up for that. I hope Suksavat, you like the class, and I will be sending a feedback form. Please fill that form. It'll be a very big help for me. Thank you, Bhagavat. I hope I could add some value to your knowledge, some more information to your knowledge. Good night, guys. Thank you, Sumant. Look forward to interact further. Good night, guys. Sure, Sumant. I'll be sending you a video containing the link to the video. I'll sending you an email containing link to the video of today's class, as well as I'll be sending you a feedback form. Also, I'll be sending you a this discounted URL price. Along with that, I'll be sending you a presentation also for this class. Okay. Good night, guys. It was great to have you in the class. I look forward for the interaction. In case you are not able to go forward for this full class, it does not mean that we do not interact. In case you have any question, please feel free to ask. We will have further more classes coming up, better timings. I mean, we are hiring really great instructors now who will be from the Hadoop background, and let's see other timing fits for you. Also, we will be running other courses as well, such as business analytics in R. So other classes might work for you. Okay. Stay tuned with us, and I hope we add some value by these classes. Good night, guys. Good night, guys. Feel free to feel free to ask me any question if you have, and stay connected. Good night, guys. Bye bye. Have a nice time.